Hi, everybody. How you doing? My name is Miles. I'm one of the solutions architects at AWS. I am stoked that you are here to do this, to learn the very first steps of saving a catastrophic amount of money on AWS. Everybody excited? Gonna have fun? How many folks think that the price drops are terrible and bad news for all customers? No hands up. Good. So we're in a good spot. I'm going to go through this. About 95% of this is live demo in our console. So pray to the demo gods for me. That's how this stuff works. But to start out, I want to go through a couple of quick things that you should know as you get started with AWS. What maybe would your first week look like? I'll go through the basic pillars of the AWS cloud value proposition. I'm going to do that stuff about this quick. I'm going to get into the demo as fast as I can so you can see what our user interfaces look like now. If you haven't looked at this stuff in about the last 45 seconds, they look a little different. We're constantly updating and innovating on top of this platform. And then my real hope is to take a big herd of folks and do as many Q's and A's as I possibly can at the end of this to ensure that we've got you ready in hand with what you need to get started. So what's good about AWS? Why would you build in a public infrastructure like this? Why would you do the cloud? So first bit is racking and stacking hardware. While awfully fun and a cool way of getting little cuts in your thumb like this one, it is in fact the same sort of thing that your competitors do, that other companies do, that lots and lots of businesses do. It's in fact undifferentiated. So this work of cabling and laying pipe and building data centers and installing operating systems and configuring networks, all that stuff doesn't make your business in any particular way different or better. Most companies that are in the business of running a laundry don't say that they're the best laundry in the world because they rack computers faster than their buddies. So, and if you are going to build a laundry company that's better than anybody in the world, you might want to do it around the world. So we've built a system that allows you to deploy in 9 regions, soon to be deploying over in China into 10, around the planet in minutes. We'll let you get into the market faster than you could any other way. And we'll make it so that you can do that confidently because you don't have to guess. So if you look at, maybe I have a big opportunity here and a small opportunity here, maybe I should bet that I have this much infrastructure to buy. With AWS, you don't have to plan in advance. You get to just pay for what you use. And that shift makes it easier to spend the right amount of money, to only pay for what you actually need. So that pay-as-you-go model makes it easier to build an infrastructure system that scales, easier to build an infrastructure system that's efficient. So from a fundamental standpoint, there are lots of different ways to build compute systems. We think we've built one that is complete, that allows you to do all the different stuff. We aren't missing any drawers in the kitchen. There are eggs in the egg basket. You can build brand new applications from scratch using very advanced services. And you can build very simple systems exactly the way that you're used to, using virtual machines to deploy software in seconds. We'll let you do that around the planet. We'll let you do that without any of the kind of impediments to getting started. That's really what this demonstration is about, that maybe other systems might incur. We've also built this whole range of services. So if you've never used AWS before, if this is the first time that you're at a summit, welcome, howdy. What we've built is a whole bunch of data centers that we'll rent little tiny infinitesimal chunks of to you for femtopennies. That's the way that we're set up. So if you want to store data, if you want to compute on that data, if you want to structure data, if you want to automate the deployment of infrastructure, if you want to manage your tools, we have systems for all of that. And those systems are built on top of, and this sort of lovely layer cake of our infrastructure and networking services. So we're going to actually look at all of those building blocks. And what I'm going to show today, you should be able to do, not for a reduced price, but for a 0 price. This is all free. This is within our free tier. Every new account gets access to compute resources and storage resources and database resources at no cost for a whole year. Some of the services even include a free tier forever. So if your application enqueues a couple of messages a day and then dequeues a couple of messages a day, no need to install an entire server to run a queuing bus. Instead, use SQS, and you'll get 100,000 messages for free. All that kind of stuff is built into that comprehensive platform that I described. So, enough of the fluffy words. Let's talk about what actually it takes. We'll be constructing a new account. I'll show you my account. This is really the one that I use every day at AWS. We're going to create a security key called an SSH key. That a key is what we use to authenticate your access to each virtual machine or EC2 instance. Then we'll create a security group, a network firewall that allows us to prevent traffic from accessing that virtual machine. Then we'll log into the instance. We'll run over and poke it. We'll make it do some work. Once we've done that, we'll show you how it's connected to network. We'll disconnect it just for fun and then plug it back in. Mess with its ability to be accessed from the public web and from you as a user. We'll show the dimensions of that. We'll also compare and contrast that to S3. So I'll show you some work with S3, and I'll show you user management with identity and access management so you know the right kinds of tools to use. Throughout this, as I'm waiting for things to load, or if I've clicked too furiously on something and it's going to take another second, I'll try to give other tips that I've learned after having poked on this kind of stuff for the last 5 years. So you will be, in fact, using a credit card to sign up. So that's the way that we've worked out to be able to do payment systems. And there's a phone verification, which doesn't work so good on microphones. So we're not actually going to demonstrate the process of typing in a credit card number, because that's also a little bit of an interesting thing to fake. So this is what the account looks like. If you're going to sign up, you push the little yellow button. Is that big enough for everybody to see, or is it squinty? Is it better like that? I'm going to take your resounding response as a yes. So if I click on the sign up button, it'll say, well, but hold on a minute. Give me your phone number. Conveniently, this is an old phone number, although I'm happy to show you mine. It is 273. And they would call my phone and say, hey, are you real? That usually takes between 5 and 10 minutes, so we won't wait for it. It also took me directly to this spot because I've been to Amazon.com before. I've used my personal email address to buy toasters and robots and blinkety lights and things. So first of the first week advice pieces, don't use your Amazon.com account to sign up for an AWS account. That's busted. Use a new email address. Go make up a fun one like I am the cloud boss at yahoo.com or I know everything about clouds at gmail.com. Doesn't matter to me. Anyone you like. But make a new address just for this so that you have a distinct AWS account. When you go, after you've created an account, you'll get access to your console. That's this button in the upper right-hand side. It says AWS Management Console. And this is hard to see, so I'll make it bigger. These are all of the different services that can be managed by the Management Console. There are a couple of weird services, edges of the AWS Web Services platform, which aren't managed through this console, but don't worry about those. For your first week, you won't get anywhere near that stuff. On the left-hand side, you'll see EC2, Route 53, that's a DNS service, VPC for controlling networks, Workspaces, newly launched today for building desktops in the cloud, Glacier for backup storage, S3 for active storage. We're going to spend most of the time over here on the left-hand side. So if I wanted to get on the cloud, if I wanted to build a virtual machine, how would I do that? I click the EC2 button, not too tough. And if you look and you squint, it's kind of hard to see, but right at the top it says West 2. That's because over here it says Oregon. I've picked a region. That's one of the facilities around the world that AWS has deployed. If I click on Oregon, there are a bunch of other facilities that I could pick. Oregon is inexpensive, tends to be relatively centrally located, but you can pick any one of these that's applicable for you and get the same resources. So if I'm here on US West, if I wanted to create a virtual machine, I'd say, well, launch me an instance. Give me one of those. So the first choice that you get is, what operating system do you want to run? You're going to run Linux? Maybe you like Ubuntu or SUSE or Red Hat. Maybe you are more familiar with Windows. You want to run Windows Server 2012, 2008. All of these in what are called the quick launch, the quick start, have been validated by AWS, are managed by Amazon Web Services professionals. These are certified images. You can build your own machine images, and there's a community of machine images that others have built, which I will affectionately refer to as the Wild Wild West. There is no validation on that stuff. It makes the Android market look like an incredibly safe place to be. Certainly recommend that you build your own images or start from trusted parties. The best place for trusted parties is over here at the AWS Marketplace, where you can buy pre-installed, pre-configured virtual machines with all sorts of good software installed. But if you're going to get started from scratch, maybe it just makes sense to use a basic vanilla Linux like Amazon Linux. So if I say next, the next option is what kind of virtual machine do I want to use? With AWS, you pick the size. Now we can change the size later, we might do that. But at the outset, you really have to select which virtual machine you need. Now the T1 Micro here that I've chosen is free for a year. One of those you can run all 24/7 and it will work just fine. Now we could build a bigger one if we wanted, but I want to show you how fast a little micro is. So I could just launch right from there, but I have other choices that I can make. So another choice to make is, do I want to run in VPC? Now, almost all of your new accounts won't have this selection. This is a legacy, a component of our transition to the virtual private cloud network interface, which now all accounts use by default. My account is old and crunky, so if you're helping a buddy out and he has an old and crunky account, he will have this choice between Classic and VPC. VPC allows additional network control, and you should use it all of the time, and we'll show you why. So the first bit is running in VPC, and then I probably want an IP address, that makes sense. And then there are these other selections, an IAM role, what to do when I shut down. All of these are safe defaults, but there's a lot to learn, you can see already, about the behavior of these tools. So an IAM role hands account credentials down to an instance in an encrypted channel to allow it to take actions on your behalf. So think about that. Your software can start hardware for itself and turn on. That's really cool. So as a software developer, rather than writing the keys and storing them inside of a virtual machine, you give it a role, which allows it to securely interact with our resources. You might also want to use CloudWatch, advanced monitoring, where you get data once a minute rather than once every 5 minutes. So the next choice is how much storage. So I have an 8 GB root volume installed on this instance, but maybe I want more than that. Let's put another one on there. Excuse me. So I can pick a specific snapshot, a previously copied EBS volume, a duplicate, a backup of a volume, or I can start from a blank disk, and I can pick any size from a gigabyte to 1,000 gigabytes, up to a terabyte per volume. I can also select standard, which is best effort performance against media stored in a big network infrastructure built by AWS, or provisioned IOPS, where I get to select exactly how many IOs per second my disk can do, up to 4,000 IOPS. So that's a big difference. Normal EBS volumes, standard volumes, operate at roughly 100 IOPS per second. So 4,000 is, only 40 times faster, no big deal. So for our demonstration purposes, we'll just start with a single volume. I might also want to name my machine, right? This is maybe indifferent to the concept of treating your EC2 instances like cattle rather than pets. Naming them makes them feel a little pet-like, so I will call this one the name of my dog, Maggie. And I might also want to give it other attributes, so I can add as many tags as I want. Things like business, unit, the team of awesome, and I might also say production level. Very broken. So that way I can keep track of this virtual machine versus others. I may want to use a service from us called detailed billing, where I'd be able to get a bill per tag. So I could say, show me all of the charges associated with the team of awesome, or show me all of the charges associated with all the systems that are very, very broken, for example. So the next bit would be security. We want to make sure that only the right network traffic can enter these EC2 instances. So probably the first kind of traffic that we'll use is control traffic, SSH. We will tunnel into the machine and be able to run its shell remotely from here. That's kind of snazzy. But we may want other kinds of traffic, like web server traffic or database server traffic. There's all sorts of different stuff. Let's start with an important choice. Right here it says anywhere. Anybody have a sensation of terror and doom when you think about people connecting from your computers from anywhere? It makes me a little nervous. So we have this button. If you say, instead of anywhere, I want it to go from my IP. So it will go out to the web and look, what is the current IP address of this instance? And it will filter our access to that virtual machine only to that IP. Now, I'm connected to a network I know nothing about, and I'm a little concerned that it's probably rotating addresses on about every 35 seconds. So instead, for today's demo, I'll allow us to connect from anywhere. But you could certainly filter down to your corporate office, to your home office, to your current location, and you can change this rule at any time. So you can even build a little script that says, when I start up my EC2 instance, open its network port just to where I am now. And then when I turn off my shell session, disconnect that port. So let's go to the next step. Hey, it's going to warn me like, hey, now really, all of the entire internet can try and SSH in? And you would think maybe that's a little scary, like, it's wide open. Does that mean anybody can connect to my computer? The answer is no, because of this next thing right after I put the launch button. It says, now hold on. We need an encryption tool to prevent access. We need a password, but a password that's encrypted, so we'll use an SSH key. And I have one already, but I'll show you what it looks like to make one. We'll create a new key pair, and we're going to name it AWS happens to rock quite a bit. And that key pair is actually being constructed in my browser. So AWS doesn't have the private side of this key. And you'll note this little warning that it says, where it says, hey, you really need to have this key pair in order to be able to get into the virtual machine. Now, you could take any AWS EC2 instance, stop it, create an image of it, launch a new copy of it, and at that time demand, hey, use a different key. If you lost this key, you can get into that new version of your original virtual machine. But we can't help you recover a lost key. That's a part of the shared responsibility of security that AWS has built. So if I download this key pair, which is a little bit of a funny label for the button since it's actually coming from inside your browser, it gets saved inside, right over here, my little downloads folder. And at that point, I can launch the instance. So while it's doing that, you can see here, I57A64, that's the little internal name called an instance ID for my EC2 instance. That's already off being built. If I click the button on it, it will take me back to a list of my EC2 instances, and you can see that it's in the instance state pending. That's the first stage of booting. So there are lots of other pieces of information and resources that have been built at the same time. So remember the security group that we made. That Launch Wizard 1 was the name of it because we were going through the wizard. That group is here. I could look at all of the rules associated. So it has that SSH open to the world, and it has no filtration on the outbound traffic. And you could also tag that security group if you wanted. You could add labels to that to keep track of what's going on at a security group level. We also built that key pair. So that key pair already exists. AWS happens to rock quite a bit. That's saved here. That's the public side of the key, not the private side, which I downloaded. You also have the volume, the EBS volume, the storage that was used to create this virtual machine. So that storage has monitoring available on it. You can see how much read bandwidth, how much write bandwidth, how much write throughput, what's the queue length against storage, all sorts of data available to you about the storage that's attached to the virtual machine. So if I go back to the instance, it's already up and running. That's for real. So this instance has a public IP address right here. If I go to this in a browser, and I hit enter, nothing will happen. I will get this weird error message that says, I can't talk to that machine. What are you talking about? That's what you would do if you were going to access a web server, right? You'd access it over port 80. You'd be connecting to that in order to be able to get to the web. Well, we didn't open port 80 in our security group, so there's no way for us to communicate with that machine over the network. So a way I can communicate with the machine is over here by SSH. I have the terminal. Now, if you look back at the console, we have this handy-dandy button. It says connect on the top, and it gives you some instructions. It says the security that you've established when you downloaded that file isn't good enough to access SSH. You're going to have to change the credential or the access permissions on that file. You're going to change the mode. So we're going to do that first. Here at the terminal, I say, where am I? Oh, let me go to downloads. And what's in there? AWS happens to quite rock a bit. Okay, well, I want that to be available for SSH. So now I've done that. That's nice. So then over here, the next question is you might want to be able to log into the thing. Now it's created a user for me, EC2 user, and it has an IP address, and it enumerates the full name of the SSH key and to run the SSH command. So I go over here, and I say, connect, and you say, are you sure you actually want to connect to this computer? And I say, why, yes, I do. And then it will connect to it. So I'll make the screen a little bigger so you can see it. Everybody read that? Okay. So there it says EC2, Amazon Linux, and it turns out, holy moly, this thing has 17 new packages to be updated. So I could say sudo yum update, and it will go off and do work. So if I look at, I say, well, yeah, do that work. That sounds great. So this 2-cent an hour computer is off compiling new packages. It's installing kernel updates. All manner of stuff is being run. If I flip over to the console and look here at monitoring, in about a minute, you'll start to see CPU utilization go up from 0% up to 15, 20% as it grinds through the process of installing all those updates. Now, probably just as interesting as getting a computer to move zeros and ones back and forth and update itself, you probably actually want to do something interesting with it. So what I'll do is install the Apache web server, and then we'll open the security group that we established to ensure that we can route traffic to this EC2 instance. Pretty simple next step. So look, it's going through the kernel now, and then it's updated Bodo, which is a Python library for instrumenting and automating AWS infrastructure. It's also built the core utilities. It's built the AWS CLI. You can see there 1.3.1. That allows you to type in commands like run me a new EC2 instance, or back my EC2 instance up, or create me a new database, or create me a new, all sorts of different stuff. So flipping over to, oh, here it's going to go through cleanup and be done in 1 second. While you are thinking about the SSH key, this tool that was used to log into the virtual machine, you might also want to think about another service from us, a thing called Identity and Access Management. That's a tool for creating a different level of credential. So each virtual machine uses an SSH key to permit remote control access. Or you could expose a web application that allows you to make changes to the system. You could control access that way as well. But AWS's APIs are their own kind of access. It doesn't really particularly matter that you have access to log into the virtual machine if a separate key, a separate credential, could be used to turn it off. Right? You want to protect that one too. So Identity and Access Management allows you to create users for your AWS account, not users for the server. And you should always do this. So this is a next first week thing that you've got to do. Every single person, when you go home and you create this account, for free, you can create on IAM as many users as you need. So create yourself an administrative user. We'll show you exactly how to do that. That user has the ability then to access the account and do all the stuff that I've just shown. But it does so in a way that's what's called rights limited. So I'll show you what that means. So if I'm going to go over here and create a new user, we're going to create a new user named AWS Friends and Nerds. Perfect. So that also creates the same browser-based user credential, a security credential to log into this account. I have to download it in order to keep it because it's sitting in my browser. There's no way to recover it from AWS. Here, if AWS Nerds and Friends, I can set any permission that I want to that user. So I can attach a policy like, I want read-only access. I want somebody to be able to log in and tell me what's going on. Maybe a support person to review what's happening in an account. But I don't actually want them to be able to delete anything or turn stuff off or turn on new computers and charge me a bunch of money. Right? I want limited control. Maybe I want full access, absolute control, but only at an individual service level. Like say, for example, I want to let somebody only log in and use EC2, but not go to that other panel and use S3 or Redshift or any of the other services. So strongly recommend another level that's very useful is Power User. So this user has access to all of the AWS services, but they can't change themselves or other users. So in that way, they can't lock you out of access to your own account. They can't do any of the kinds of bad actor things where they're messing with each other's users. So that's an important tool. These same user policies are what are used to create IAM roles, so you can empower a computer to take actions on your behalf, your software to take actions on your behalf. That's a pretty powerful tool. These are pre-built policy templates, but you can also use our policy generator to build your own, or write out by hand the syntax for new policies if you're so inclined. So if I say I want to give this guy power user access, select apply policy, now I have that access. If I grab a security credential like a password, here's a password. I want to create an auto-generated password, or maybe I'll assign a custom one. So, ooh, I bet you I typed that wrong. There you go. So now I have a password. How do I use this user rather than the user that I used in before, my email address and my password? In order to use that user, I have to use a different URL to log into the account. So my AWS account alias, for anybody who wants to try some other username and password, is really, really awesome. So right here, if I go instead of, you can see up here, console.aws.amazon.com. If instead I go to this URL, let's make sure I know my username because that was hard, AWS Friends and Nerds. If I go here and paste that in, it asks me to log in. It says, well, you're going to really, really awesome. I'll make that bigger. But what's your username? And it's AWS Friends and Nerds. So I can sign in using that user. And now, say for example, if I go into IAM, remember I gave myself power user credentials, it'll show me some error messages on here. It says, now hold on a minute. You are not authorized to perform a listing of all the different users. You are not authorized to perform a listing of the account aliases. No, those credentials are not a part of your account. You can't go in and touch those things. There isn't anything that this user can do. He can go in and click on the list of users. He won't even be able to see himself. It'll say, no, your account doesn't have access to that stuff. So that's the kind of control that's available with identity and access management, which I encourage all of you to exercise. So over here on the EC2 instance, which is now through the process of updating its kernel and installing the critical patches, the next step would be to install more specific software, like sudo, I came disconnected. So how do I get back in there? I connect again. Crunch, crunch, crunch. There's for new folks, there is an alternate to SSH called MOSH, M-O-S-H, which is short for mobile shell, that has connection persistence and a couple of other things that would retry that connection, which is kind of cool. So I'm still at the same spot. I'm logged now into the same server. If I go sudo yum install httpd, that's the HTTP daemon that makes the Apache server turn on. I say, yeah, do that. And it'll go off and download some of the dependencies that are required. And then I'd say sudo aphec, or there we go. So it has this little OK thing. It says, yep, I've turned on HTTPD. I'm ready to go. Now, if I go back over here to the browser, and remember the IP address out here, this 51.186, still not going to work. Not going to go. Because we still didn't open the security group, right? So if I go over here to the EC2 Management Console, it's up on the left, and I go down here to the security groups, and I remember that my security group was called Launch Wizard 1, and I say I want to edit my security group. I'm going to add a new rule. I want to add a rule for my friend and yours, HTTP, and I'll let that open from anywhere in the world. And I save it, and let's see how fast I can do it. Get over here. And there it is online. Right? So those security group rules changes, they happen typically in sub-second. They're very, very rapid. If I reload this, I'm reloading the page from the browser. If I come back over to the management console and say, wait a minute, I screwed up. This is bad. I don't actually want people to be able to access my website. That's a terrible idea. Well, let's turn this one off, delete it, save it, and I run over here, and now it's a spinny wheel. It's not working right. So you have real control. These are your virtual machines. You can do what you want with them. You have the ability to prevent people from accessing them. You have the ability to control the manner in which they access You have that capacity. So let's put it back on there. If you look, dang, oh, not there. If I go here, it's back online. So if I go back to the EC2 instance, here, if I sudo service stop, I also control the web server directly, so if I go back here and I run the test page, it'll give me a different error message and say, hold on a minute, Apache isn't running. It's not working. So, but that seems like a relatively complicated process to just serve things by the web. Does everybody think that was too many steps? It's like a lot of clicking, like lots of listening to me say dumb stuff. So let's do it appreciably faster than that. Let's go instead to a service over here called S3. Works almost exactly the same way. You create a bucket, a container for objects, just like that virtual machine is really a container for your stuff, right? And you create buckets which are themselves little kinds of websites. Some of these websites can't be accessed from the internet and others can, and we'll show you how to change that difference. So I have a website here, or a bucket here says from Grace. That's got some files from Grace. Looks like it's data from the Scottish census. Don't think I'll be processing that today. If instead, what I wanted to do was create a new website, a new place. I don't want a folder. I want a new bucket. Now, buckets are globally unique because they are websites. They are URLs. That's what the Uniform Resource Locator means, right? So they have to have a unique name globally. So you can't make a bucket named aws.amazon.com because we've got a website called that already. Too bad, so sad. So you have to name it something funny, which is always my favorite bit. Really incredible, fun stuff. Now, if you're going to build a website, instead, you'd want this to be a real domain name, right? It should be exactly the same as your fully qualified name. You can do that without the www, but you probably want the .com or the .org or the .biz or .io or .whatever. So let's make a website like super delicious, magnificent, fun clouds. And we'll put that in a region. So important note for the folks that are just getting started. There's US standard, which is a little wacky, and then there's all the rest of the S3 regions which behave exactly the same. What do I mean when I say a little wacky? There was a question outside, so I'll clarify that. There's a difference in eventual consistency inside of US standard. US standard is slightly likelier to be inconsistent between distant lookups. So if you have somebody that's over here in Brazil and somebody that's way over there in Botswana, and they both look at an object immediately after you wrote it, US standard takes a femtosecond longer to update those differences. So if hard consistency is an important component of your workload, you'd want to pick an explicit region to have as your S3 target. S3 still operates in an eventually consistent way, but US standard is a little different. So let's say we're going to do it in US standard. That's just fine. For a website, that's probably going to work just great. If I create the bucket, you'll see down here, super delicious, magnificent, fun clouds. That's the name of my the name of my bucket. Inside of that bucket, I can create objects. What is an object? So an object is a file that I'd want to upload. So let's take, I don't know, Dropbox, photos. How about, what would happen if I was in a dune buggy and flipped it upside down? Let's set the permissions of that as being public and upload it. So now this file, think, 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 chew, 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 smash, smash, smash. This file is now online. And that's the URL for it. And if I hover over it, there you can see me, oops, accidentally, inappropriately driving. This is not safe. It's almost as unsafe as not having what? And using the root account on your AWS account. You're supposed to use an IAM user. If you don't use an IAM user, you're flipping your motorbike. Don't do that. So this URL here, if I copy it, put it in the browser, you'd see it this way. Oh, there. See, that's maybe a little easier to see. I look good there. Nice helmet. Maybe the pants don't fit so well. If I didn't want that online, remember when we were closing the security group on the EC2 instance, we said, nope, we don't want to get into that anymore. If I don't want this online, I have to change its permissions. So it has permissions, you look over here, pull this down, I have two grantees. Me, the account, Miles at AWS, this is my user account on Amazon, so I can download the file from inside Amazon resources. I could copy it between buckets, I could create an EC2 instance and download it to there. And then the other permission is everyone else. So if I turn off open download from everyone else, and I go back over to this picture, and I reload it, it will give me this error, which you cannot read, and I will make bigger, and it says access denied. So that's kind of the same function as that EC2 instance. Now, why are we showing you these two different models, two different ways of basically doing exactly the same thing? The EC2 instance has lots of additional controls and power. You can install software, you could use it to grind data, you can do all sorts of interesting things there. An important note, it's 2 cents an hour. So the second one you start, that first one's in the free tier, but the second one you start, it costs 2 cents an hour. So you can imagine, you do the math on that to work out what it costs a month or a year. Now that file, if all I wanted to do with that server was to serve this picture, or even to serve 100 pictures, the files cost now 3 cents a gigabyte a month on AWS. A gigabyte, this picture is of 100K or 20K. So how much does that cost a month to run? Hundredths of a penny, right? Not 2 cents an hour, hundredths of a penny, maybe even thousandths of a penny an hour. So if you're thinking about, reducing cost, having a cheaper infrastructure, being able to build systems that scale, might be better to build tools that can fit inside of S3, can be operated as static. So how many folks are familiar with like static site generators like Jekyll or Octopress or any of the good stuff there? Those are ways to take advantage of S3 as a hosting environment rather than EC2. So EC2 becomes, the way I like describing it is, if you have zeros and ones and you want to keep them, those go in S3. If you have zeros and you really badly need to change them into ones, that's what you do in EC2. It's only for the wiggly stuff. So it's important as you're thinking about designing systems that you'd go through each of the different layers of your application and understand how much static stuff is in there, how much could you pull out and host in a simpler, cheaper, faster, more scalable way. So other pieces that you might take a look at as next steps, maybe on the second or the third day while you're taking a look at AWS. So one of the things lots of people use EC2 instances for is to install databases. Well, databases are complicated. Storage for databases can be difficult to configure. Implementation of a backup plan or protocol can be complex. Making those databases highly available can be tough. So we have a service for that called Relational Database Services. We'll build a SQL Server or MySQL or Oracle Server or PostgreSQL database on demand, and we manage all of those work tasks for you. You don't have to fuss with any of it. Pretty nice. If you want to take, say, for example, and set that DNS name for superawesomewonderfulwebsite.com and point it to an EC2 instance or an S3 bucket, you can use Route 53. That's hosted managed DNS. Super cheap. Very, very powerful tool. If instead you were going to build, rather than a relational database, a NoSQL database, you might use DynamoDB. You might cache that data using Elasticache. You might want to build all of the stuff that I just showed you as a single executable command. You want to template that. That'd be called CloudFormation. Makes it super simple to deploy. Maybe instead you want to keep track of systems for brand new development. You are actually a software developer, you're building new code. You could use Beanstalk to deploy Java applications, Node.js applications, Ruby applications onto these same building blocks, S3, EC2, these other pieces, but in a coordinated, managed way. Now, a couple of other last things that I want to show you before we get done. First is another one of those things that every customer should do right out of the gate. This service right here in the middle called CloudTrail. Maybe I did that too fast. CloudTrail. CloudTrail is a service for recording all of the actions that you take in your account. And this seems like kind of a waste, right? Who could ever break into your account or cause any kinds of problems? Well, if you're writing your username and password down on large whiteboards and then putting it in front of windows and angling them just right for satellites overhead to see them, you might have a problem. Or if your developers accidentally put your access key and secret key into GitHub, hint, do not do that. You might want to be able to figure out who did what inside of your account. So CloudTrail actually writes all that stuff down, but we won't do it for you by default. You have to turn it on. And the reason that is that you're going to end up paying us one of those fractions of a penny to store this data for you in S3. So that way it's in your account, it observes the separation of roles and responsibilities around security that's a part of this shared security model. So really encourage everybody to turn this on. Again, it's going to be like some fraction of a penny inside of your account. It's really a good call. Another component that may make a lot of sense to take a look at is the stuff that's not in the main area of the console. So over here on the right, you see me logged in as this IAM user, right? There are some limits to what that user can see inside of your account, like your bill, like your payment model. So that's another thing to ensure as you're handing credentials down to developers. You don't want them to see your, or to be able to change the credit card information or the account access email or things like that. So another piece that's important, if you look here, is a thing called CloudWatch. Now we showed a couple of charts and graphs from CloudWatch before, but I actually want to show you maybe a more important part of that. Where did CloudWatch go? Look at that. They move it? Oh, they made it green now. So CloudWatch has a very special kind of an alarm. So I was talking about that free tier where you don't pay us anything to play around in the cloud. It would probably make a lot of sense if you had an alarm that would go off if you went over that free tier. You probably want to know when you're going to spend more than $0. So I want to show you how to do that. So here in the management console, I would create an alarm. I say, okay, I want an alarm. And it wants to know which metric from AWS. So see all the different stuff that it's tracking. It knows how fast my DynamoDB tables are going and how many EC2 instances that I have running and all sorts of different measures and reports about the behavior of my cloud infrastructure. But probably the one we're interested in is this simple one right here called total estimated charge. So if I click on that guy and I say USD, you'll see my account, which is burning money at a catastrophic rate. I am currently spending, it thinks, if I'd stopped doing anything right now and didn't make any changes, that I would spend right at $2,900 at the end of this month on the stuff running inside of my account. And then I have some cool stuff in here. So that's okay. But for you, you probably want that to say 0 at the outset and maybe $1.50 after that as you're growing more and more usage of services. So let's talk about creating an alarm for that. I say, okay, USD, estimated charges. This piece, next. What's the name of this alarm? Well, I'm going to call the name Watch My Wallet, please. The description is please don't break the bank. Woo! So here, if you can see, the little red line is where the alarm is. It says at $0, send me what kind of a notification? Well, I can notify an SNS queue, which is an automated messaging system from Amazon, pretty cool tool, or I can just have it send me an email, which is roughly the same thing. So the people paying, that's a good notification list. We should probably email them. And here at $0, that alarm would go off immediately for me since I'm already spending vastly more than that. Maybe mine, because I should be better about it, maybe mine should be $3,500. So then you can see the red line is above the blue line. At some point here in the next couple of days, that blue line will cross it and I'll get sent an email. Now, in order to be able to send an email to someone, it has to be registered in this SNS list. So I'm going to send it to myself, and the email list is, say, this is my email if anybody wants it, miward@amazon.com. That email has to be approved, just the same as if you signed up for an online account at a new place. They would send you a check email to make sure that you really wanted to sign up. This will do the same thing. It'll send an email to my account saying, are you sure you want to be notified about this stuff? And you have to say yes. And then if the alarm goes off, you'll get an email that says there's an alarm, there's something going on. That works pretty good. So I'd hit create alarm, and we'd go off and build it. Watch my wallet, please. So those alarms can also be set on other stuff. Your EC2 instances, performance, how much CPU you're using. You can also, there are a whole bunch of built-in measures, right? So EC2 will keep track of CPU utilization, disk reads, disk writes, all the network traffic. If it's failed a status check, And it'll do that for each of your different EC2 instances. So I can say I want to see CPU utilization for those two different computers. One of those isn't doing very much, and one of them is getting some work done. That's kind of cool. So those measures can also be set for alarms, same way as your bill. You can also create, off of any of these measures, auto-scaling groups. So EC2 instances that turn on and off based on actual load. And those are all triggered off of CloudWatch metrics, which are then used to drive that. So you might think, I want to trigger off of something other than that's in this list. CPU utilization isn't it, disk read isn't it, network isn't it. I want to trigger on memory utilization, or I want to trigger on free disk space. So we have built-in scripts that allow you to execute writing those metrics into CloudWatch. So for both Linux and Windows, you run a little script on your instance or a scheduled task, say, for example, on Windows, and it will write those measures in, and you can scale off of those values as well. So there's a whole bunch of stuff, obviously, in EC2. We've seen just the surface of it. We looked at EC2 instances. We created a security group. We created volumes. We created key pairs. Here I'm looking at my account here in Northern Virginia, and I've got bigger stuff, one called Giant, and one writing a test for Bright, and something here running a C1 medium and a CC1 exit large. It's important as you're thinking about your use of AWS that you don't end up on a tab different than you expected. We have lots of customers that lose their virtual machines. I promise they're back in the region where you left them. Go back to where you were working. So here I go back to US East, and there's Maggie again. I haven't lost Maggie. If you want to clean up what you've built, it's important from our perspective that it's just as easy to destroy all of this stuff as it is to stand it all up. So if I right-click on this guy, there's a bunch of options, but one of them is terminate. And we get a lot of questions about the difference between stop and terminate. So stop means suspend processing on the EC2 instance, so turn off the virtual machine, but don't throw it away. I might want it back. And so that also means if you used EBS, remember we used an 8 GB root volume for the machine. If you use EBS, that drive persists. So EBS costs 5 cents a gigabyte a month, so you can either work out that's 40 cents a month. If I turn off my EC2 instance, if I stop it, I'll pay 40 cents at the end of the month for that drive. Now you have some EBS volumes included in the free tier, but I'm explaining at larger usage. Now if you terminate, the machine goes away. We'll delete the EBS volume. We'll deregister the machine's ID from our list. It won't show up in your console anymore after some delay where we pull them all out. And that makes sure that you're not being charged at all for that virtual machine. That's the difference between the two. So if I terminate it, it will say, hey, hold on. And it says the default action for this one is not to delete it. So there's an interesting bit. You can change the default behaviors of AWS resources. So another thing you could do here what it said, the default action is for the root volume to be deleted. I could set an alternate where I don't actually want to delete the volume. Maybe I want to do forensics on the disk from another virtual machine. I could also set it up so that I can't terminate it from the instance, because that's only 2 clicks, right? Maybe I'm clicking too fast and I click on the wrong virtual machine. So I could click on here and say, where is enable termination protection? Ding, ding, ding. They moved it. I think that's my screen is too small. Further up? Down. Where is it? Up, down. Now we're just playing the up-down game with you guys just to have fun. No, just kidding. So change termination protection, and then it would say the current setting is disabled. No, I want to enable it. And then I can go over here and click it and say, yeah, terminate the heck out of that thing. And it'll be like, what? No, hold on. Yeah, totally terminate. Oh, wait. I just want to click on that so bad. It won't let you do it until you turn that back off. So just another way to protect yourself from accidentally touching stuff. So we have about 5 minutes left. We went through a lot of different stuff. Any questions? Yeah. So if you say capture an Amazon machine image, the question is, when I capture it, is that the one that I'm currently working on, or do I have to start a different one from that? No, when you say create image, I'll do that right now. I can do without a reboot a copy of that virtual machine to a new image ID, and that's the one that I'm running, and I could run as many copies of that one as I want. Okay? Yep. So those AMIs can be shared across accounts, and you can add permissions and subtract permissions later to access them. Other questions? Yeah. To do a demo of auto-scaling, it is, but probably not in the 3 minutes that we've got. I can show you off to the side, though. Sure. So the question is, where does Elastic Beanstalk fit in? Elastic Beanstalk is a control layer that manages these basic building blocks. So if I start EC2 instances and log into them and screw around with them, I could run a website. Or I can turn on Elastic Beanstalk and say, build me a website. And it will stand up EC2 instances and load balancers and all the different tools that would be needed to make a scalable website without me actually logging into the virtual machine. Kind of snazzy. Kind of snazzy. But at any point, that's kind of the nice bit. Rather than it being a hidden environment where now once you're inside Beanstalk, you can't go change things, and we're controlling it. It's a clear container. At any point, you could log in and change the way that it works and break it and change it, manipulate the operating system, manipulate the software you've installed. You just turn off the Beanstalk control layer that sits over the top. Any other questions? Back here. So the question is, an S3 volume, is it possible to share it across my EC2 instances, sort of like NFS? So NFS is the critical word there. S3 as an object store doesn't adhere to the NFS standard and doesn't really store the NFS metadata that will allow it to do and behave as like a Windows file share fast enough to do normal document collaboration. Now, there are lots and lots and lots of tools that establish that metadata layer, right? So Dropbox is a customer of ours. They sit on top of S3. They establish the storage of the data on S3 and then a separate metadata layer to enable the syncing. So if you want to use Alfresco to install the same service on top of EC2 to share files across AWS, that works pretty well. You can have everybody access S3, but they access it as an object store, not as an NFS mount. So it's more like uploading and downloading from a file server than it is copying and pasting from your desktop. Yeah, further back. Yep. Sure, so the question is, if I build something on behalf of another customer in my account, how do I give it to them? How do I hand it over to them? So a couple of different components. First, if you're building something for productization, my hope would be that the software that you use to design the infrastructure, say either CloudFormation or OpsWorks or those or Chef or Puppet, third-party tools, all that's been captured and encapsulated in some way. The software installed on the EC2 instances can be backed up using an Amazon machine image copy, right? You duplicate the image. So then you'd share all of the images required to build the system to the remote account, copy to them the control code to boot all of those machines, and hit play. Now there's moving it under their account, like literally relabeling them isn't something that's possible in the AWS system today. Yeah. Yeah. Mm-hmm. Yep. So the question is, each customer using his MySQL Server databases gets their own database inside of that. So MySQL Server supports hosting multiple databases. RDS is a MySQL server, not a database within it. So in the same way, you'd log in using a MySQL credential, you'd be able to use PHP, MySQL admin, and create 1,000 databases inside there, no problem. Yeah. Go ahead. A request ID. Okay, yeah. That's actually the log of data that's output by the construction of a new event. That's an ID that you could look up in CloudTrail to see the list of the events that occurs. Sure. I should probably ask you follow-up questions about what it is you're talking. Maybe we'll do that offline, but right after this. Yeah, in the back? Or over here? Yeah, go ahead. It's you. Yeah. Mm-hmm. Sure. So the question is, if I'm using DynamoDB, that's a hosted, managed NoSQL database from AWS, and I access it from two different regions, is there a reduction in the consistency? So if I write a piece of data from this region and then I want to read it from over here. So Dynamo replicates internally to the region all of its data, and at read request time, irrespective of where you read, you select, that's actually a part of the request, whether you want a consistent or an eventually consistent response. So if you select, I would like a consistent response, doesn't matter whether it's in the same region or a different region, you'll get the same answer, a consistent answer. If you ask for an eventually consistent answer, you can imagine that inside of a given region, we'd be able to route more closely. So you're talking about a difference in milliseconds. Maybe a millisecond or so later, you'd see the eventually consistent result in a remote lookup. Cool. Yeah. Yep. Yep. Sure. So the question is copying data from a non-EBS or a local ephemeral disk. The micro instance that we started didn't show any of those, but larger EC2 instances have some small local storage. That storage goes away when the EC2 instance turns off. So if you do that stop action, not even terminate, just stop, the data is deleted. So you can imagine you do some experimentation, you're building something up, you install a database, you install a bunch of stuff on that local ephemeral disk, and then you want that data to not die when the virtual machine goes away. So you're literally copying data. You create another EBS volume, or an EBS volume, attach it to the instance. You can use DD, you can use a file copy, you can use whatever you want. But at some point, you have to copy the bits from one side to the other. You just do that inside the virtual machine. Yeah, if you do it with a block size copy, a DD copy where you're moving the bits, you have different geometry between the two targets. So you can move all the zeros and ones just in an emergency backup that way, but it's probably better to use a file system level copy operation to move data, robocopy for Windows users, Xcopy, any of the other kinds of application level, CP for Linux users. Most database engines, if you change their storage target, will want to restart the storage engine. Yep, that's true. Yeah. It depends on the latency that your customers expect. We are phenomenally well connected to the internet, stupefyingly well connected to the internet. A non-trivial fraction of the internet sits on top of these systems. So your ability to access us is as good as any place in the world. But if you're on the other side of the planet, you're potentially hundreds of milliseconds away. Now, for some applications, downloading a picture, right? If you have a system in the east coast of the US and you're in Singapore, 200 milliseconds latency isn't very fast, but if you're just downloading images, it works fine. It means 0.2 of a second later, you get the picture than you would if you were in New York. But if you're trying to log in like for workspaces, and literally every time you move your mouse, that's a communication back and forth to our instance, you're gonna want that latency lower so that you can move more quickly. So depends on your application. If it's an application where lots of stuff changes all the time really fast, you'll want instances and servers distributed around closer to your customers. If it's more of a file transfer, data movement, access it every once in a while kind of an app, then latency typically is not as big a problem. I work for an e-commerce company, and we have lots of them all over the place. Thanks, everybody. We're out of time. I appreciate it.